Welcome back. This is part 2 of our guided tour of the Boilermaker scaffold. And for this video, we're going to talk about our database connection, some environment variables again, seed script, and resource deallocation. So Dakota, why don't we go ahead and take a look at our database folder?
Sure. Okay. So the database folder is...
So we put it in server, which Ashi actually once told me something that I agree with, which is the server and the database are really not the same thing. They're often running on different machines. Just because the database is down doesn't mean that your server app shouldn't be able to run and report errors to the front-end client code. But because, at least here at Full Stack, while we're learning, we often are running the database alongside the server. I think that's why it ended up in this folder. But just something to keep in mind.
Gotcha.
So let's take a look in server. All right, there's a DB folder.
Oops.
And
I'm still in Vim in my head.
And in there we've got several files and folders. We've got a models folder, and we have two top-level files here, DB and index.js. The way that Boilermaker works is we set up our database connection in DB, we use DB in all the models, and then index pulls in all the models and ties them together with associations. There are clever kind of tricks in order to do all this orchestration, but that's been one of the simplest and easiest to replicate versions of this pattern that we've come across.
Gotcha.
So let's look at the db.js connection. We're not going to really look at models in this video. Okay, so what have we got here? Looks like one thing is we are actually requiring in package JSON. Did you know that you could require JSON natively?
I did not.
Yeah, it just imports it as an object.
Oh, that's nice.
And the reason we're doing this is we want to get the name of the project to figure out what database to try to connect to.
Mm-hmm.
We could have it so it just automatically defaults to Boilermaker, but then you have to find everywhere in the source code where the string Boilermaker appears and change it. And we just want to have that in one place, which is in our package JSON.
Exactly.
So if we look at the README, it actually tells us we should change the name of our project. So let's go take a look at that. Okay, so setup, we already did this. We created a remote, we pulled, we pushed, and now we're going to edit the project name and description in package JSON and Travis YAML. Let's go ahead and do that.
Right. So we've got package JSON open, per usual. Okay, and then I forgot what name we used.
Something with bake in it. Boilermaker.
Yeah, Boiler-Baker, right?
Boilermaker. Important note, the name can't be anything. It has to follow the rules that are allowed for Node projects. So we can't use capitals, I think, or spaces or certain other things. NPM will actually get mad at us.
That makes sense. I mean, it has to be an identifier that, first off, you can run as npm install, and then so it can't include things like quotation marks, bangs, $signs.
Right. Okay, so we've changed it in package JSON. Let's also change it in Travis YAML. We haven't talked about Travis YAML so much yet, but I want to show you where we're going to do this. It's in the before script line. You see how we're doing p-c create database Boilermaker test. We're going to change that, in this case, to Boilermaker test. And the dash test is in addition to whatever we put our package name. So we have to keep that in there. Now, locally, we are going to have two databases. We're going to have our development database that our seed script will create stuff so we can, while we're doing front-end development, see content, and that'll be Boilermaker. And then we're also going to have a testing database, which the test script can clobber as much as it wants, erase everything, put stuff in, erase everything, and it doesn't get in the way of our development. So that'll be our Boilermaker-test database.
Great.
So let's make both of those in the command line.
Sure. Okay. So I use p-SQL. But you can't make it. You can't create a database in p-SQL. So I need to get out of this. I need to actually use the command line create db.
That seems pretty crazy to me.
I don't know. This is just the way it works.
Yeah.
I didn't write it. So create db, Boilermaker, and then Boilermaker test.
Okie doke. So we got our two databases. And if we go back to our db.db.js or whatever it was called, there we go. What we can see is we're pulling in the name of the package, and we're going to decide to connect on the line with process m of database URL. There's 3 possible database connection strings we're going to use. When we create that new SQLize, If the database has been specified in the environment as an environment variable, we're just going to use that. But if it doesn't find a database name in the environment, it's going to assume it should connect to a Postgres that's on the same machine we're running the server. This is what we do when we have local testing or even on Travis. Now, even in that case, there's two possible different databases we're going to connect to. Normally, if the server just runs, we're going to connect to Boilermaker, which is our dev database. But if we're in testing mode, if node env is test, then we'll connect to Boilermaker test.
Right, and you can see that here in this ternary, where it says process env node env that we talked about before. Is that equal to test? If so, then append -test. Otherwise, don't put anything.
Yep. Now, the way that this gets set locally, if we look at our scripts for package.json, when we run something like npm start dev, our node env is development, not test. Or if we just ran start node server, our npm environment would be whatever it is on Heroku, which is probably going to be production or maybe something else. But when we run test, we manually set the node environment to test, saying, when you connect to the database, please connect to the testing database.
Cool.
Okay, let's go back to our DB connection. I think that's most of what I wanted to show there. We turn logging false. We export this database connection so we can use it when defining models and listening and connecting and all that kind of stuff. And now we have one more interesting thing here, which is a bit of resource cleanup. So in Mocha version 3, it used to be that as soon as all the tests ran, it would force quit whatever your process was. And that masked a potential mistake people could make, where if they opened up some asynchronous thing or they had a set timeout or something like that, normally you'd want to clean that up at the end. You'd want to like cancel that, close it down. But Mocha was just hiding that was still going on by force quitting the entire process. In Mocha version 4 point something, and now we're on 5, they changed that behavior. So that if there was any dangling async still waiting around, waiting to do something, the process would not end and the test would not end, and you'd have to manually Control-C to get out of the tests. That works fine for a human who wants to see if all the specs are passing, but can you tell me where that would fail, where that would not be very helpful?
Well, any sort of automated testing. So, for instance, on Heroku, if Heroku runs your tests whenever it runs, or if you have a continuous integration environment set up, that could also be a problem, like Travis or Circle CI.
Exactly. So that was a problem because then we saw all of our tests on continuous integration. They would run the tests and then they'd hang forever and they'd never move on to the next step, which is saying, okay, like hit that green check mark or deploy to Heroku or whatever.
And the worst part about that is there's no error code. It's just sitting there.
Yeah.
And the log is sitting there. It says it's going, but...
Yeah, it says pending. It's a little yellow circle. You're like, what's taking so long? And it's really hard to track down these dangling async things. It's like, where did it start and why is Node not quitting? And there are packages out there like, why isn't Node quitting? And things like that. So let's take a look at this one. If we're in testing mode, we want to make sure that after all the tests run, we release the database connection because we're not going to use it anymore for anything else. So this after is a global Mocha hook saying after all tests have run, please do db.close, which will release that connection, after which there's going to be no more async running, so the whole thing is allowed to exit naturally and gracefully.
Very nice.
Is there anything else in this file? That seems to be the end, right? That's what those tildes mean?
Yep.
Okay, so that's our database connection string. The next thing I wanted to take a look at today was the seed script. So if we look at our package.json, the script that's called seed basically just runs node script seed. It's a small alias for running a node module. Let's take a look at that. Okay, so what have we got here? We're getting in the database connection. We're also pulling in one of the models for Sequelize, which we're going to look at in a future video about authentication. And this thing makes a really big deal out of this C script being built in async await. By the time we made this video, the entire code base is async await.
Right.
But originally, when Boilermaker was written, this was like the hot new thing. So let's take a look. We have a seed function, which at a very high level creates 2 users. What else do we have below this seed script? We've got a run seed, which is not a great name differentiation from seed. And this is a more high-level orchestration kind of thing. Here we attempt to do the seed, which is going to actually put stuff in the database. If it fails, we're running this thing called process.exit code. We're setting it to 1. The previous version of Boilermaker used to do something like process.exit as a function. We actually don't want to do that because process.exit is going to kind of clobber away what we were talking about before. We want our process to exit naturally because there's no more work left. And if there is an accident, somebody left some dangling async, we want to know about that and not just like quit it. We want to find out about it so we can fix it. So this is a little bit finicky, but we set the exit code to something non-zero to indicate that it will be an error, but we don't exit ourselves. We let node naturally exit.
Yeah, and this is the exit code of the actual process that's running, and that's why we set it to 1, because it's like a shell error code.
Right. You might also note we've got a try, catch, and finally. So finally is not used very often, and when it is often used, typically for resource cleanup, letting go of async stuff. So what are we doing here? We're doing that DB close, similar to what we were saying with the Mocha testing. This is not testing, this is seeding, but it's the same idea. After we've successfully seeded, we can say to SQLize, we're not going to need the database anymore. Feel free to close the connection. And since that'll go away, Node will have no more async resources left to manage, and it'll say, oh, all the program is done. There's nothing more I could do. Now I can exit. Anything else in here? Oh, yeah, this require module main business. So we were talking about this before we started recording. So why don't you explain to me what's going on, why we would want this?
Sure. So you can do 2 things with a JavaScript file using Node. You can require it by another file, but you can also run it itself. So for instance, our script does node script seed. And so you can distinguish between those 2 situations by this require.main attribute. Because what's happening is that's going to say what is the module name that this is running as. Is it running as the main thing that was called, or is it running as something that was required elsewhere? And this is a common pattern across languages. Like even Python has a similar thing where you do if their thing is a dunder name, which dunder means double underscore x double underscore. So double underscore name double underscore is a special variable that gets populated. And then in this situation, if you're running it specifically, it's set to dunder main. And so you do if dunder name equal dunder main, then you call like some function. And so this is the same thing here. And this in these higher level languages somewhat emulates the way that a lower level language like C runs, where you have a main function. And that is that's what runs whenever you run your program. And I think also Haskell has something similar. Is that right?
Yeah. So every Haskell program has a bunch of pure functions in it. But at some point, you need some sort of script that interacts with the real world. Haskell itself, the language, doesn't do that, but it lets you create a sort of script that if you sign it to the main variable, that's what gets turned into an actual runnable program.
Right, yeah. And so this is the same kind of thing. This is saying this file is meant to be called, from the command line by itself. Now that's not to say that you can simply execute this file. Some files you can just simply execute on the shell command. And those files at the very top would have what's known as a shebang line. This one doesn't have that, so we know that we need Node to call this file.
Yeah. So at a very, very high level, what we're doing here is allowing this module to do 2 different kinds of things. It can actually be an executable, something that you run from the command line using Node, or this module can act like a bit of a library, something that gets required into other modules. I think that's pretty much it for the seed script. The reason that we actually have this module require main is if we do run node seed, we want to run the seed script. But sometimes we might want to test the seed script. If we test the seed script, we don't actually want it necessarily running right away. We want to be able to, like in our test, selectively run it or not. And so if we are using this in our test, if we're requiring it over there, then we're going to use it like a function and not like a script. Okay, so that's the seed script and main module, and also a little bit about like resource deallocation. If we're done with something async, we can release it, do a bit of manual garbage cleanup, and that allows the process to exit gracefully. That's it actually for this video, much shorter than the first video, thankfully. And in our next one, we're going to talk a little bit more about the backend, our server, some of the API routes and middlewares. See you then.